Hello everybody, welcome back, and today we're going to see how to graph a quadratic function in a standard form. First of all, let's try to understand which type of example we can have when we have a quadratic function in this form. If we have y equals to 2x squared plus 4x minus 2. Well, we need to identify the value of a, b, and c. In this case, a is equals to 2, b is equals to 4, and c is equals to negative 2. It will be very helpful because the first thing we need to do is to find the vertex. And to find the vertex, we know we have an x and y component. Then, first we're going to find the x component, and then we're going to find the y component. To find the x component, we're going to use this formula, minus b over 2a. Using a, b, and c, now we can know where the x component of my vertex will be. In this case is minus, the value of b is 4, I'm just going to plug in the values. 2, always going to be 2, and the value of a, in this case, is 2. Minus 4 divided by 2 times 2 is 4, and 4 divided by 4 is negative, is 1, and negative 1 because of this negative sign. Now, we're going back to our function, and we already know the value of x. X is equals to negative 1. We're going to plug in this value instead of the x. 2 times negative 1 to the second power plus 4 times negative 1 minus 2. Y is equals to, remember, here is important to remember the ordered operations, or pentas, if you want to remember like this. I'm going to write it here. The first thing we need to do is the parentheses, then the exponent, multiplication and division, left to right if we have both, and finally addition or subtraction. Okay, then we have parentheses, but we don't have operations inside, but we have exponent. Minus 1 to the second power is positive 1 times 2 is 2, plus 4 times negative 1 actually is minus 4 minus 2. Then the value of y is minus 4 minus 2 is minus 6, plus 2 is minus 4. We already found the 2 point of my vertex, the value of x, which is negative 1, and the value of y, which is negative 4. Now let's try to put our vertex in a coordinate plane. Remember, the vertex for this problem is negative 1, negative 4. That means always the first position is for x and the second position is for y. Negative 1 in x, and now I'm going to move 4 units down. 1, 2, 3, 4. My vertex is right here. Now, we need to graph our parabola, but we just have a point. We need at least 2 more points because remember, a parabola is something like this. Because of a is positive, we already know my parabola. The parabola is going to open upward. But how can I find the other 2 points? Well, I need to choose one value from the right. We're going to focus in the value of the x. And we're going to find a value to the right of -1 in this case, and to the left of -1. Well, to the right of -1, x is going to be equals to 0. I could choose another value. It's not necessary to choose 0. It could be 1, 2, 3, 4, 5, etc. But in this case, look what happened. If x is equal to 0, it's going to be easier to solve it. It's an easier operation than to choose 1, 2, or 3. Then instead of x, I'm going to write 0 squared plus 4 times 0, -2. This is equals to -2. Then I have a point. For x, I have 0, and for y, I have -2. I know that this is going to be another point of my graph. When x equals to 0, the value of y is -2. Now, if I want to find the other point, I could do the same. If I move 1 unit to the right, I could move 1 unit to the left and try with -2. But graphically, I know in the same position where my x is for my vertex, I have an axis of symmetry. And my axis of symmetry will be an imaginary line that helps me to graph, because an axis of symmetry, everything in the right is going to be exactly the same as everything in the left. It's like a mirror. Then, if I move 1 unit to the right of my vertex, the value on y of my function is going to be -2. What happens if I move 1 unit to the left? Then it needs to be the same value too. The value of y needs to be equals to -2. We are ready to graph. The only thing that we need to do is join the points. And now we have our parabola. Another main topics we can find in this Another important things we can find in our graph is, for example, we need to find the domain. The domain, we can understand it like where my graph is going to exist in the axis x, in the x-axis. Okay? Then, if you see, that's why we wrote this arrow, because our graph is going to come from -infinity to positive. Then are going to be all the real numbers. And what about my range? My range are all the values where my graph is going to be in the y-axis. My graph is not going to go under -4 in y. It's going to be the last number. But it will exist to all the positive, these negative numbers and all the positive numbers in y. How can I write this? Well, it's go to -4 to infinity. And as we already said, our axis of symmetry is in x equals to -1. Because my parabola is open upward, we have a minimum value. And the minimum value are going to be my vertex. And that's it. We have represent our parabola, and we found the domain, range, axis of symmetry, and identify it as a minimum or maximum value. Remember, if my parabola is open downward, we're going to have a maximum value, and it's going to be in the vertex too. See you!